The following video is a recording of a lecture from Genes to Galaxies, the 35th Professor Harry Messel International Science School, presented to high-achieving Year 11 and 12 students from across Australia and 10 other countries.
Okay, so excuse me with my voice. My children have been a little bit sick and it's finally caught up with me. Hopefully my voice will last to the end of the lecture. So I've been asked today to give you guys a lecture on evolution, but cosmic evolution. So we're going to go on a bit of a journey. But instead of a journey through space, we're going to go through a journey through time and take a look at where galaxies come from, what they are now, and where they're going to go into the future. And a lot of the focus will be on our own galaxy, our home, the Milky Way. So I'm going to start with a little bit of history. And of course, you all know that this year is the International Year of Astronomy. So it's 400 years since Galileo first raised the telescope to the sky. And what Galileo did for us is he actually opened a brand new topic of voice is already starting to fail. A brand new topic in understanding the universe. Before the times of Galileo, historically, most of human civilization looked at the sky, saw stars on the sky, and attached some sort of pretty picture or some story to what they could see there. Or there's some sort of animal on this side, there's something going on that side. What Galileo did for us when he first looked at the sky is he realized that there's more going on out there in the universe than there just being a static picture for us to look at. And of course, one of his first famous observations is he took a look at the planet Jupiter, and what he saw is that Jupiter wasn't alone in the sky, but was actually accompanied by 4 little bright dots, which were realized to be moons of Jupiter. And so these moons orbit Jupiter, and so there's something else going out there in the cosmos. Rather than just pretty pictures, there's something actually happening. This was the start of what we would call modern astronomy and modern cosmology. And soon after the work of Galileo, we had the work of people like Brahe, Kepler, and especially important Newton. And what Newton was able to do for us is to show that we could take our understanding of the universe, our laws of physics, the equations that we use to describe what goes on here on Earth, and we can actually apply them to what we see on the heavens. And of course, what Newton showed is that the force that keeps the moons orbiting around Jupiter, the force of gravity, is exactly the same force that causes an apple to fall from the tree. Now, that was a great starting point. It gives people like me a job, of course, being a modern astronomer. But what it also did for us is it opened up a whole new range of questions. Okay? We could see that we could apply the laws of physics onto the objects we see on the sky. So what's out there? Okay? What is it that we actually need to explain? Now, the first ideas of cosmology, i.e. the study of the entire universe, was that the universe is effectively a very simple place. We have the sun, it's a star, and people thought it was probably just one of an infinite sea of stars that stretched off in all directions. Now, of course, we know that can't be true, because, as you know yourself, that when you go and look out at stars on the sky, they're not just randomly scattered everywhere. There is actually some sort of method to the madness. And the most important feature is we can see stretching across the sky a bright band of starlight known as the Milky Way. So people realized that maybe we don't live in an infinite sea of stars. What it actually looks like is we live in a group of stars, and this group must have some structure. Now, I understand you've already had a lecture from Naomi, and so she's given you a bit of a tour of the Milky Way, but I'm just going to remind you about what our home actually looks like. After a lot of detective work, it was realized that this big group of stars in which we live, the Milky Way galaxy, is actually a very large place indeed. A lot of detective work over several hundred years led us to the conclusion that the sun is, of course, not alone in the universe, but actually shares this local patch of the universe with roughly 200 billion other stars. Now, these stars aren't distributed in some sort of amorphous blob. Our Milky Way has actually got some very pronounced and very beautiful structure. What we have, of course, in the center is we have this bright bulge of stars, and surrounding that, there's a spiral disk. There's a pattern in the disk known as a spiral wave. And our sun is just one star sitting out in the outer regions of the galaxy, going around with many billions of others. This, of course, is an artist's representation, and what we would really like to do, of course, is see what our galaxy truly looks like. And of course, to do that, we need to step outside the galaxy and look back. Now, considering that today we're celebrating 40 years since man landed on the moon, and we haven't actually gotten any further in that period, it's going to be a long, long time until we can step outside of our Milky Way galaxy and peer back in it and see what our home looks like. But one of the nice things about our local part of the universe is that we're not alone. We actually share this local part of the universe with another galaxy very, very similar to our own. And located roughly 2 million light years away, which is next door cosmologically speaking, is an object known as the Andromeda Galaxy. And to all intents and purposes, the Andromeda Galaxy is a mirror image or a sister galaxy of our own. It is a large spiral galaxy, and if you look at this picture, it has a bright bulge in the center, and it's surrounded by this extensive disk of stars, a spiral disk. So while we can't step outside our own home, we can actually have some sort of idea of what our galaxy looks like. Now, the Andromeda Galaxy has been known since ancient times. It wasn't known that it was actually a galaxy, but a bright, fuzzy blob in the sky in the constellation of Andromeda has been known for a long, long time. And of course, with modern images, we can reveal that it, like the Milky Way, several hundred billion stars living together. So that's kind of a nice picture. So perhaps that's the universe. Yeah? There's the Milky Way, and then there's the Andromeda Galaxy. But of course, like a good salesman, there's always more. And the thing that we really have come to appreciate in the last 10, 15 years is that the universe is actually a very busy place indeed. Now, this is a small part of an image known as the Hubble Deep Field, or the Ultra Deep Field. I can never remember which one's which. But it doesn't really matter. This image was obtained by taking the Hubble Space Telescope, of course, one of the most powerful telescopes that we have, orbiting the Earth, and doing something very simple with it. Basically choosing a patch of sky that appears to have nothing in it, no stars or anything, opening the shutter, and then waiting, and waiting, and waiting, and waiting. And basically doing an exposure over hours and hours and hours and hours and days, etc., etc. Now, of course, what you're going to do is if you do that kind of experiment, you're going to be able to see very faint things. And when these images were first looked at, it was realized that this patch of sky that appeared to have nothing in it was actually crammed full of things. What are these things? Well, you can see all these fuzzy blobs, etc., but it doesn't take a big stretch of the imagination to realize that the object that we're looking at here is a spiral galaxy. And in fact, if you look at that one there, and that one there, and that one there, and in fact, if you look all over this image, there are loads of spiral galaxies. In fact, there's loads of galaxies altogether. And so what we've realized is that we have our home in the universe, the Milky Way galaxy. We're accompanied by the Andromeda Galaxy, but those are just two galaxies in an estimated population of roughly 1 billion galaxies that we know of in the observable universe. So as a scientist, I want to understand why does the universe look like this? Why do we have all these little island universes, these galaxies scattered all over the heavens? And can I apply my laws of physics that I know from the laboratory here on Earth to what I see on the sky? The picture actually becomes slightly messier when we take a look at galaxies in detail. It would be nice if all galaxies were identical, if they were all nice big spiral galaxies, but they're not. But it turns out that there's not too much to worry about. Essentially, there are two kinds of galaxies. We have the beautiful and wonderful spiral galaxies, like our own home, and the rather ugly and boring elliptical galaxies, which are just fuzzy blobs of stars. Okay, we live in a spiral galaxy. We can be sort of biased about this viewpoint. One of the interesting things, though, is that not only do galaxies come in two particular types, what's kind of amazing is when you consider the range in size. Now, as I said, our galaxy, the Milky Way, is essentially a largish kind of galaxy, roughly 200 billion stars in it. You can find elliptical galaxies about the same size as us, but in various places in the universe, you can find elliptical galaxies which are many times larger. So instead of stars being there in the billions, you can get stars in the trillions, all living in one object. So there are some monster galaxies scattered through the universe. On the other end of the spectrum, there are some really puny-weeny objects, and these are known as dwarf galaxies. And instead of having billions of stars, these guys have tens or possibly hundreds of millions of stars in them. So cosmologically speaking, they're actually quite tiny. So the big question is, how are these guys related? Are they just randomly thrown out there in the universe, or are they linked somehow? Does the existence of one influence the existence of another? We have one more clue to look at, and this is where are galaxies in the universe? Now, as I mentioned, we actually share our local patch of the universe with the Andromeda Galaxy. But what do you find if you go out there, instead of just looking at our galaxies, you start to look at loads and loads of galaxies? Plotting their positions on the sky, what do you see? Well, again, like our ancestors, you might consider the picture might be something like the stars that they originally thought of, randomly scattered through the universe. So perhaps galaxies are just thrown down like sand on the floor and have some sort of random pattern. The result actually is very, very different. So this picture here, it's a little bit messy, but it's quite straightforward. We live in the middle. And what we have here, these pizza slices, are looking out into the universe. So looking at a patch of sky, traces out a pizza slice as you go off into the universe. Now, as I mentioned, the Andromeda Galaxy was only 2 million light years away. The distances that are being covered here are now going out to 2 billion light years. So this is now looking at a very large chunk of the universe. And what we've got in these two pictures, each of the yellow dots represents the location of a galaxy. So this picture was created using a telescope up in Coonabarabran in New South Wales, which was designed essentially to map out the positions of objects like galaxies and allow us to make these 3D maps. And the first thing you see that when you look at this picture, quite clearly, the galaxies aren't just randomly thrown down. What you should be able to see is that there are giant walls, and there are filaments, and there are great big holes, rather affectionately known as voids. There are regions of the universe where we don't have galaxies at all. And in fact, if you wanted to find an object to best describe the distribution of galaxies that we see on the sky, it looks like a sponge. Galaxies